Alright, here's my latest upgrade on my computer. I went from the 8350 to the 1800X Ryzen 7 chip, running the Asus Crosshair 6 board and Corsair Vengeance 3000 megahertz RAM. I believe they are 2 times 8 gig sticks. But primarily this video is about the water cooling setup that I have here. I ended up making this more efficient by shortening the lengths of tubing, and I also had a pump that died on me, the SwiftTech pump. But the system starts here in this reservoir where I added so I can actually get more water capacity to the system. And then I have an EKW pump down here that also has a built-in reservoir. So between this reservoir and this reservoir, I have added more water capacity to help cool the CPU more and help keep the system cooler for longer periods of time. So I'm going to close that. That's the power supply for the pump. That's just stationary, and it just runs the pump and the actual temperature gauge over here. So the system then comes up and goes to the evaporator on this air conditioning unit. I believe it's a 5000 BTU unit that I took apart and attached these 3 240 millimeter radiators to it, and then also I attached a 10-inch auxiliary fan here to help give me the airflow I need, and also to prevent the AC evaporator from freezing up. And that is controlled by this power supply here and a pulse width modulator. So I have a potentiometer here that I can turn to dial in the speed to help prevent this from freezing up, which it is right now, but I'll turn that on later. And then the system goes from this output on this radiator into the CPU block itself. This is a Thermaltake AM4 block, I believe, and I have some paper towels, as you can see, around the fittings because I am dealing with condensation. I do have dielectric grease around the block and the actual socket itself. I do need to insulate these tubing next, but for right now, there's enough heat in the case to prevent condensation from forming, but it doesn't really work that well. I have to wipe these tubes pretty much every hour to keep it from producing droplets. But then it loops back down and goes underneath the mini fridge, and it goes into the freezer itself. This is where I have the 20 feet of 3/8 inch copper piping. This helps pre-chill the water before the reservoir, and this comes right after the CPU block itself. The output of that is over here, and then it goes back down into the reservoir and the cycle starts over. I have the temp gauge hooked up, which is right here. This is in degrees Celsius. The probe itself's in the reservoir, and it's also, like I said, controlled by that external power supply there. And the system runs on average between, I don't know, that's pretty low, 3.7. That's about 36, 37 degrees Fahrenheit, I believe. I don't know, I have to look up the conversion. But that's pretty chilled water, and I've gotten good results. If we go over here to show you some homework monitor and CPU-Z. Maybe even a fire strike score, but as you can see here, I have the 4.268. Temperatures have been moderately low. I'll go back up, and I've been satisfied with the cooling and the overclocks I've been able to achieve on this chip. Right now this is my 24/7 overclock, and I've been at this for about 3 weeks now. I had run a lower clock speed of about 4.22 for about a month now. I decided to go a little higher, and here you can see click on the main board, memory, and so forth. I am running 2 Fury cards at the moment, and then I'm going to click on, let's see, the Fury, 2 Fury cards and 1800X on Fire Strike. Yeah, I know the graphics has not been improved yet, but I did get good results on this. Much better than my previous computer that I had, but quite satisfied with the cooling abilities and the overclock I was